Do you think, David, we can start?
Well, I guess we can, yes. What do you think?
Yes, okay. Yes, that's fine. So I start. Thanks a lot. Thanks everyone participating to this first online lecture. I'm quite proud to be the coordinator of such kind of project, and I'm really happy to see for the first time all the selected PhD students are together now. I know it's online, but it's the first step. It's good to meet all you. And I will spend just 10 minutes of introduction of the project, just to say which kind of project we are talking about, which are our main aims in this project. And then I will leave you to David and to all of you to introduce yourself and start the discussion about your PhD project. And okay, I share my screen. Just I have. Can you see my screen?
Yes.
Okay, great. Just few slides to introduce our project. This is our logo, maybe you know, and maybe you have seen our web page. Otherwise, you have to go there and look inside our web page. And it's happening. Yes. As you know, it's quite a big project. It's a project funded by the European Commission, and inside the Marie Curie projects, we are a lot of institutes, a lot of university, other institutes. In particular, we have 8 beneficiaries that are listed here in different countries of Europe, and 15 partners all around Europe, as you can see in this picture, and both academic or non-academic partners and beneficiaries, because the importance of this kind of project is also to give a possible link between the academic world and the private world. Here the logos of our institutes, but I don't want to waste time on this. It's important to everyone to know that which are the main objectives of this kind of project. As I told you, is inside the Marie Skłodowska-Curie Action, and in particular is a doctoral network project. The main objective of a doctor network is, as written here, to implement a doctor program by partnership of organizations from different sectors across Europe and behind, and to train the students, the PhD students, to stimulate what we call doctoral candidates, to stimulate their creativity, enhance their innovation capacities, and boost their employability in the long term. We have been funded for 2.6 million euros for 4 years, and many of this money is for all of you, all the PhD students, because will be for the salaries, but also for the research that you will do inside your PhD projects. Going inside TREAD, that is the acronym of our project. The aim is to train a new generation of researchers to tackle the challenge of earthquake forecasting, and in particular in complex tectonic setting, and using integrated observation and physics. So the idea is to develop novel integrative approach to seismic gas analysis in Europe and in Mediterranean, trying to bridge the gap from small scale laboratory experiments to large scale observations, so different scales, and also to establish physics-based earthquake modeling, bridging time scales from millions of years to fraction of seconds in complex tectonic settings. So we want to work in different space scale and time scale. And the last objective is to transfer earthquake geology and computational modeling to hazard and risk assessment, adapted to the need of government, industry, and scientific stakeholders. We have selected 11 doctoral candidates from 7 different countries, and we are quite well balanced. And we have, if I remember well, 6 females plus 5 males. And these are the work packages of our project. So we have 3 work packages that are the scientific ones: earthquake observation, earthquake physics, and earthquake hazard and risk, together with the training work package. And David is the leader of this work package. Communication and dissemination one, Maria Ortuño is the leader of this, and the management one, where I'm the training part, but also communication dissemination is a really important part of this kind of project, because as I told you, the focus are the doctoral candidates. So we have to try to train in the best way the doctoral candidates. Just a few words about the work packages. These are the other WUPI leader. As I told you, I'm the leader of the project management, and David is here, is the leader of the training and personal career development. For the scientific one, earthquake observation, CNRS in France, and so Lucilla Benedettis is the leader. Earthquake physics is the Utrecht University, so Ilona van Winter is the leader. And the third one is earthquake hazard and risk is GEM in Pavia, the Global Earthquake Model, the leader, and Marco Pagani in particular. And the other one that is, in any case, a really important part in such kind of project is the communication, dissemination, and exploration of results. And Barcelona University, in particular, Maria Ortuño is the leader of this work package. These are the main person you will meet and discuss and exchange during the next 3 years of your PhD projects. So you have to be in contact with us for sure, together with obviously with the supervisor of your PhD project. Please remember that this is a global project. You have to be not only focused in your PhD project. It's important to work on your PhD project and have exchange with your supervisors, but also you have to be connected with all the other doctoral candidates and all the leaders of the work packages, and in general with all the supervisory board, because into the supervisory board will be also people from the partners that are not beneficiaries. Going into the science of the 3 research work package, the first one we call earthquakes observations. The main aim is to characterize the source of strong earthquakes using paleoseismology, morphotectonic, geological observation, INSAR, geodesy, and seismic monitoring, so seismology, to detect the seismic and the seismic process. As I said before, we want to cover a different time span and different spatial zone with different aims in the different PhD projects. The second one is we call earthquakes physics, and the main aim is to determine how physical processes and properties affect earthquakes and seismic hazard, and in particular to push forward to merge physics-based approach to probability seismic hazard assessment. And the third one is earthquake hazard and risk, with aim to provide training for key tools for the reliable, efficient, physics-based and time-dependent seismic hazard and risk assessment in the future. Sorry for this one. Okay, just a few words on the upcoming common appointments. As you know, next Wednesday, we will have the first complementary skill course, and it's called Data Management and Policies, including open access and fair data. Is an important request by the European Commission to have also short courses on these complementary skills. So it's important to follow these courses, and it's also important to collect information from these courses. If, obviously, will be some hours from 2 to 6 p.m. So please participate, but also participate with question and trying to understand this kind of skills. Then we will have all the online lecture. David, later we will give you some details on our program of the online lecture that you have to follow to start your training part. And then we will have soon, from 27 to 28 of November, the first workshop led by Lucilla Benedetti and organized in Aix-en-Provence in Serres Laboratories. You will, I think you received the details of the workshop, and I hope many of you will participate in presence. I know that some of you have some problem with the visas. I'm really sorry about that, but we hope to have more or less all of you participating in presence. In any case, we will organize also a Zoom connection for the workshop for the parts that where it's possible to have this kind of online interaction. Then the day after, again in Aix-en-Provence, we will have our first annual meeting, and so together with all the doctor candidates, we will have some professors and researchers from the different beneficiaries and partners. So all the 23 institutes that are inside the project will be present there and together with the students. So we will have a discussion both on scientific parts of each PhD project, so all the free work package, scientific work package, but also on different aspects. It's our first meeting all together. We had last January, sorry, we had the kickoff meeting, but we were not all together, and in particular, we had no students inside this kickoff meeting, so it's important to participate to this first annual meeting. Then on 13th of December, we will have the second complementary skill course, and you will receive information about that. And we are planning organizing the first training school, that is the other way to train in presence the doctoral candidates. Probably the location will be Sicily, is to be confirmed, but it's quite. We are quite optimistic about that, and will be next April. It's important, I think, for you, doctoral candidates, to have an idea of the decision-making structure of this project. So we have the European Commission that have to be check our work, and inside the TREAD project, we have a project management team that is composed by the project coordinator, so myself, and the European project manager. Then the core of the decision-making structure is the supervisory board that have one representative for beneficiary plus one representative for partner organization. You will have soon all the names of this participant of the supervisory board. And then it's important to know for you that we have to have two elected doctor candidates representative and one also from the external advisory board. So it's important that you have to start to meet inside the doctor candidates and decide who will be your representative inside the supervisory board. Then, as I told you before, we have the work package teams done by the work package leaders plus the supervisors. We have an external advisory board where we show you some words about that. We have some points of contacts and officers like this listed here. And in particular, we have, it's important for you that we will have doctor candidates committees. All of you are inside this committee. And two of these will be the representative that will be inside the supervisory board. It's important to have this involvement of the doctoral candidates in the project governance. We have to work together and grow up together. And the project, the core, I repeat that the core of the project are you, are PhD students, because the funds by the European Commission came for this main aim in particular. This is the external advisory board composed by 4 different researchers from different countries and different backgrounds that cover all the knowledge we will cover during this project. So Jean-Philippe Wack from Caltech, Martin May from KAUST in Saudi Arabia, Jonathan Walker from UCL, so UK, and Paolo Bazzura from US in Italy. And the external advisory board will ensure annually high levels of strategic direction, provide oversight and expert advice, and ensure the connectivity to the international research and the industrial community. So it's their work is also quite important, in particular to this connectivity to the industrial communities also, and not only to the research. This is my email. Please don't hesitate to write me for any question, any doubt, or everything you have on the project, and visit also our website. I think you will receive a request of some information to put your data inside our webpage, and so the webpage will grow up again in the next weeks, also with your information. And that's all, thanks. And okay, I stop my sharing the screen. If you have some question, I'm happy to answer. Otherwise, I leave you, David, the coordination of the other part of this first online lecture.
No questions? Nobody? Good. Okay, so I will say a few words about the training part, and especially the online lecture. So that's the first one today. It's a bit of a particular one this time, so it's just an introduction. But then it will be proper teaching, you know, in a couple of weeks. So I will share the timetable, which is here. Well, you all have access to this, and I'm sure you've already had a look. So it's in construction. So for the time being, we have the few lectures that are planned. So so you can see this, and but the later lectures are to be confirmed. So TBC stands for to be confirmed. So what I will do in any case is to let you know a week in advance. So just to remind you that there will be an online lecture the next coming Monday. So all the lectures will take place on Monday at 4 p.m. except for 2 very peculiar lectures. This one that you will have on this Wednesday, so for the whole afternoon, and then one also in December, so a whole afternoon on Wednesday again. But apart from this, all the lectures will take place on Monday. So every fortnight, every 2 weeks. Again, I will remind you each time about the subject and about the fact that you have an online lecture. So, I mean, the online lectures need to be attended because that's really important for you, for the training. So you all have different backgrounds. You can come from physics, from geology, and so on, from mathematics. But I mean, the whole project, the TREAD project, is about, you know, earthquakes, but seen from all these different perspectives. So not any of you has a broad view on the whole domain. So it's important for you to acquire basically, what has been lacking in your courses so far. So if you come from physics, I'm sure you quite you're not very knowledgeable about geology and so on. So you need, really to attend those lectures, because they will you will benefit from them quite a lot. The program is not fully developed at the time for the time being. What is important is that the general scheme is the following. We're going to take the first 30 minutes for general discussion, basically, implying you. So we will ask at the beginning. We thought that you could all give a short summary of what you've been doing for the last 2 weeks each time, but then it's too short. So what we will do is we'll ask 3 of you each time to give a short presentation of your progress. And the idea is really to discuss, with you and with all the colleagues that will attend the beginning of the lecture. So on our sides, on the permanent researcher side, we will ask everybody to try to attend this 30 minutes, and then they will probably leave for the rest of the lecture, and you will be on your own with the lecturer. But for what we will do is you can see here. So this Wednesday there won't be any such 30 minutes, because it's already a long lecture for 4 hours. But the next one is in 2 weeks' time, the 20th of November. So it's by Michele Flandries about the architecture of fault zones. And then these 30 minutes will be taken for these 3 DCs, so 1, 2, 3. So that's John, Mike, I don't know if I pronounce your first name right, and Aurora. So you can give a 5 minute or a few minutes presentation on what you've been doing, and if you haven't done much, because that's only in 2 weeks' time, then just try to say what you will do in the next few weeks or next month, and then and so on. So the next lecture then will be in that will be at the beginning of December by Giulio Di Toro, and then DC 4, 5, and 6. So that's Naire, Elizabeth, and Nolwenn will again give a short presentation, and so on. So I haven't filled in all the Google Sheet, but I will do. And then if we find that you don't have enough time, then we will ask only 2 DCs to present their work each time. We will see how it goes. I don't know if you have any questions at this stage. No questions, so don't hesitate to interrupt me. So the Zoom link is always the same, and then the whole calendar is there. So you have the workshops and the training schools as well, and are indicated, plus the big conferences like the AGU, EGU, and so on, plus the holidays, even though the holidays are different from one country to the other. So and whenever we have definite dates for the meetings and the workshops and so on, we'll I will indicate that on the Google Sheet. So the training is mainly through the online lectures and the workshops. So there will be 4 workshops and 2 training schools. So the training school are a bit longer, they may, about a week, and the workshop are shorter, 2 days in general. So if we go down, so you have another that's a 3-day workshop. And then the training school, well, that's in some time now. So you'll have time to think about that, and then 2 more workshops at the end of your PhDs. Well, that's all for now. All online lectures will be recorded, so it can happen that some of you, because of I don't know any issues, or if you're on the field or whatever, cannot attend the lectures, so they will be recorded. And the lectures are open in any case. So if you have a fellow PhDs in your labs that could be interested, don't hesitate to tell them about specific lectures. The lectures are intended to be to start with a broad view on the field. So it's not for specialists, even though we'll ask the lecturers to to be a bit more specific at the end of the lecture, so maybe to enter more into the details. But most of the lectures can be attended by any of you, obviously. So again, don't hesitate to tell your PhD fellows in your labs about it. Well, that's all for me. I don't know again if you need more details, or if you have any questions. Okay, no, good. Lucilla Benedetti was supposed to say a few words about the first workshop. She cannot attend the meeting for personal reasons, so I think she gave you all the details. So I don't know if you really need to know more. Well, if you have questions, just ask Lucilla, and that's all. So what we will do, I ask all of you to send me a couple of slides, mainly to introduce yourself and your subject, so everybody knows each other. So we will go through all the DCs, the 11 DCs. So I've compiled all your presentation, and I have to ask you to apologize for the compilation, because some of the presentation didn't go through very well. So I try to do the best I could, because I work with OpenOffice, so it's a bit different from Microsoft PowerPoint. But I think it should be okay. So I will start, and the first DC is John Gallego. So stop sharing that screen. So I will go through the slides. Just tell me when you present to go to the next slide, and I will do that. Okay. Done.
Yes, I'm here. Thank you, David. I still don't see the slide.
Yeah. I'm opening it.
Yeah, thank you.
Yeah. Okay. So I think you should see it now. So John, that's your say.
Okay, thank you very much, David. So hello, everyone. So I'm very pleased to meet you all. I'm John Gallego. I come from Colombia, especially from the northwestern region, from a town close to Medellin City. So I'm 36. So from my personal side, I'm married. I have no children. I love hiking and spending time with my family and my friends. So regarding my education, so I finished my bachelor in geological engineering at the National University of Colombia. Then I had the opportunity of doing my master in earth science at the universities of Bern of Fribourg in Switzerland. And last year, I also have the chance of doing a specialization certificate in geological risk and climate-related risk at the University of Geneva, the CERC program. So since my bachelor, I think I've been really interested in the topics of quaternary geology, especially neotectonics, geomorphology, hazard zonation. I have some experience as a professor, as a adjunct professor, in teaching some courses in a university here in Colombia. I work in some private and public companies regarding geotechnics and risk management and so on. So I think my motivations here within the third project is the willing to learn. I hope I can learn a lot from you, from your knowledge, from your experience. I'm also very happy to create a network, to have a really nice relationship and friendship with all of you. I'm very passionate about academic research, and I hope the success of the project, and I hope also we can contribute a lot with the results. So thank you, David. Can pass the next slide. So I will introduce my PhD project. So I'm still here in Colombia. Actually, I'm going to start properly the PhD on 1st of December, and the hosting university mainly will be the University of Barcelona. So the PhD project one is the earthquake timing in complex fault zone, new approaches in paleoseismology. The PhD will be on the supervision of Maria Ortuño, Lucila Benedetti, and Moritz Kirsch. So the investigation question and the aid on the project will focus on the improvement of the location of earthquake chronologies, some event horizons, especially by integrating some new techniques in paleoseismological trenches and bedrock scarps. One of these techniques will be the fault ruptures and fault segmentations detail mapping using LiDAR-DM and other photogrammetric tools. Another technique will be the innovation with hyperspectral imagery for inspection of paleoseismological trenching. Finally, also the use of advanced chronological techniques such as cosmogenic nuclei, luminescence dating in paleoseismological trenches, fault breccias, and bedrock fault scarps. So the study area will be in Spain and Italy, especially in the Apennines, Catalan coastal ranges, and Eastern Betics, where we can find different tectonic settings and a variety of fault systems. I think the expected result will be the paleo earthquake record of the study areas. But I think the most important will be the workflow and methodology for these new techniques, and how can we apply them in the paleoseismological studies to better understand the behaviors of the faults, and serving also as a future students worldwide. So that's it, and thank you very much, and nice to meet you all. Thank you.
Thanks, John. If anybody has any question. Oh, by the way, so one of your targets will be Central Apennines, and I need to emphasize that many of you will actually work on Central Apennine with very different perspectives. So just to let you know all, so it will be interesting to see what you can do, John, with this. Okay,
Thank you.
good. No questions? Okay, so hold on. So DC2 is Maike. So I don't know if I pronounce your first name right. So you need to tell me.
Yes, it's Maike. So it was all right.
Okay. Good.
Okay.
Yeah.
So hello everyone. I'm Maike Fontijn, and I'm the doctoral candidate of THREAD Project 2. I'm 24 years old, and I am from the Netherlands. And since I was a kid, I was fascinated with the mountains, and that's why I started studying earth sciences. I did a bachelor in earth sciences at Utrecht University, followed by a master in geophysics, also at Utrecht University. And during my master, I developed a keen interest in seismic hazard and earthquakes, and I did my master thesis about the effect of subducting seamounts on the seismicity in subduction zones. And that got me really passionate about researching earthquakes. So I started looking for PhDs, and that's when I found this project. Can you go to the next slide? So my project is project 2, named Combining INSAR and Seismothermal-Mechanical Models to understand earthquake sequences in complex fault systems, applications to the Central Apennines. I will work with Erwan Pache, Ilona van Dinter, and Anne Soquet, and I am based at University Grenoble Alps, which is a great location for me with my love for mountain sports. And I also have secondments at Utrecht University and Tre Altamira in Milano. Next slide. So about the project, a new study of INSAR in the Central Apennines raised interesting questions about the mechanisms there that cause uplift and horizontal strain distribution. However, there are still some challenges when we want to use geodetic data for seismic hazard assessment, and these are separating the interseismic deformation signal from other sources of deformation, and also there's a limited knowledge of the fault geometry and rheology, and the geodetic data only captures a small portion of the seismic cycle, as it is only 10 to 20 years, while the seismic cycle is hundreds of years. And then there's also an uncertainty if the current interseismic signal is representative for multiple earthquake cycles. And in my PhD next, we are trying to overcome these challenges by combining the geodetic data with seismothermal-mechanical models. Next. And these seismothermal-mechanical models have a visco-elastoplastic rheology that simulate geological evolution and the seismic cycle. So they can simulate multiple earthquake cycles. And I'm gonna use these models to form and test hypotheses about the fault geometry, rheology, seismogenic depth, faulting mechanism, strain accumulation, etc. in the Central Apennines. And we're also going to use it to assess the accuracy of geodetic inversion for slip rate assessments on individual faults, and to see if the interseismic signal of one cycle is representative for multiple earthquake cycles. And then the expected results are next, to obtain a map of surface displacements in the Apennine with just the interseismic deformation, to improve the geodetic inversion for complex fault systems, to produce these earthquake sequence simulations for the Central Apennines, and to perform a statistical analysis on these models and compare it with nature. Yeah, and that's it. Thank you.
Thanks. Very good. Yeah. No questions? Okay. So I think it's yeah, Aurora, you're next.
Hello, hi everyone. Can you hear me?
Yes.
Okay. Perfect. Nice to meet you all. I am Aurora. I am connecting now from ETH Zurich, where I'm based. I'm Italian from Naples, where I studied physics and where I graduated in March this year with a thesis in seismology. And I can really tell how excited I am to be part of this project, because I think that my background and that my interests perfectly match the values and the objectives of the thread. So today I'm going to introduce you to briefly to the key points of our future work and project, which is called the seismic signatures of aseismic processes. We can go to the next slide, where I introduce you to some definition of a seismic and seismic processes. And a seismic process is a phenomenon that can be detected and analyzed by geological and geophysical tools, but which is not apparently accompanied by any kind of seismic activity. On the other side, seismic processes are represented by all the events which are associated to the release and the consequent radiation and propagation of energy within the Earth in form of seismic waves. So we, of course, want to study how these two different categories of events are related, and if and how seismic processes could affect seismic hazard, even if seismic processes are not clearly and directly associated with any seismicity. So we will focus on seismic processes which occur within the Earth, under the Earth's surface. And in the next slide, I am providing you with a very simple and clear scheme showing how, for example, fluid injection can influence the condition of stress on a fault plane. Here you can clearly see how, for example, in the area directly surrounding the injection point, the fault experiences a process of strengthening with a consequential seismic slip, while in the once that a certain distance from the injection point is exceeded, the fault seems to weaken, and this weakening promotes seismic slip, which means earthquakes. So there are many experiments, observation, and numerical modeling which evidence how fluid flows and migration are able to trigger earthquakes, and also plays a role in controlling swarms, which are particular seismic sequences characterized by specific characteristics. And then we will also take into account of another kind of a seismic process in the next slide, which is the slow slip events, which are also known as fault creep. As well for fluid migration, also slow slip events are related to seismicity. Moreover, often slow slip events are observed to occur on the same fault where we observe also seismic slip events. And when something like this happens, we can talk about coupled fault. And one example is the central Sant'Andrea fault, which is shown in this figure, which presents several segments with continuous transitioning of fault coupling, creep rates, and seismicity pattern. And in this figure you are looking at, you can observe the map of the coupling, which is this kinematic parameter used to understand in which area of a defined fault a seismic slip is more likely to occur with respect to the regions of the same fault in which the distribution of earthquakes is denser. So at the end, to conclude, in the next slide, I resume the main purposes we would like to achieve with this project. The first one is the use of deep learning tools in order to enhance seismic monitoring of earthquake sequences, and to also improve the detection and characterization of seismic signatures associated to seismic processes, which could be really hard to detect and to monitor. And of course, we want also to deepen our knowledge and our understanding of seismic processes, and investigate also its predictive value for anticipating earthquakes. So in the end, we would like to develop a seismicity model which take into account both seismic and the seismic processes, and which could also have a predictive capability with respect to the current models. So that's it. If you have any questions, I'm here.
Thank you, Aurora. No questions? So we can go on. Okay, so DC4 is Naire, so I'm again not totally sure I pronounce your name okay.
Okay, hello everyone.
Yes.
I'm Nayara Sabur, and I'm from Iran. And at first I want to introduce myself. My bachelor was in geology, and after that I was admitted to the Master of Science graduated program of Research Institute for Earth Science, and for MSc project, I was work on structural maturity of some seismic faults and scarp diffusion of some seismic faults. And after that, I work in seismotectonic and seismology department of Geological Survey of Iran for 10 years. And now I'm in project DC number 4 for linkage between linking fault damage zone mechanical and geometrical characteristics with fault seismic history. For my MSc project, I work very closely to this topic to determine the structural maturity of almost all active faults of Iran based off geometric properties of superstructure, long-term slip history, and earthquake acceleration data processing. I have calculated the diffusion coefficient of three seismic fault scarps as well, and we diffuse the reconstructive primary shape of scarps by the code that I wrote in the MATLAB software. And for this project, the next, please, the next, this is my project, and the next one. As you can see in this, we can find the different behavior of produce the rupture on at the surface. That's because of the some inter-segment about the strength of some inter-segment that stop the rupture, and so we are going to work on it. And the next slides, you can see that in this slide, and we are going to work in geometrical characteristics of rupture, the fault lengths, major segmentation, displacement, stark variation, and associated secondary fault network. And on geometrical features and fault slip rate and seismic history, and with all of them we can make a relationship between the characteristics of superstructure and the history of seismicity of fault. And the next slide. This is the selected sites that we are going to work on it. The Velino Magnolia Fault, the Vado di Corno Fault, and the Rocca-Bretto. I'm sure I hope that I have a good reading of them. And the next slides. This is the surface rupture of superstructure of some these three faults that we are going to work on them in Central Italian Apennine. And the next one, this is Vado di Corno fault, and last one, the Roccaprietro fault. And in my project, my project is supposed to be closely related to project DC number 5 and 6, but I will enjoy and welcome cooperation with all other projects. Thank you very much.
Thank you, Naire. Okay, so if there's no questions, so we can go on. And Elizabeth, so DC number, yep, DC number 5.
Hi, everyone. Yeah, I'm Elizabeth, and I'm happy to be here and meet you all. I'm gonna shortly introduce my project and tell a little bit more about myself. So my project has the title Flow to Friction and Back in Carbonate Rocks, and we want to investigate the rheology of carbonates during the seismic cycle, and that especially at the frictional plastic transition zone. Okay, next slide. So firstly, I want to tell a little bit more about myself. And I was born in the beautiful and large country of Kazakhstan. But then I moved to Germany, where I complete all my entire study. And I study geosciences at the Ruhr University in Bochum, specialized in geophysics from a master program. For my bachelor thesis, I looked at free oscillation in boreholes and modeled them numerically. And for my master thesis, I measured elastic wave velocities in the anisotropic Freiberg gneiss formation and compared the ultrasonic, sonic, and seismic velocities. So I always had great interest in everything related to seismic hazard and experimental rock physics. And at latest, since my master thesis, I am also highly curious about how smaller scales affect bigger scale processes. So this is a very exciting project for me, which I'm doing in Utrecht University. Next slide. At the HBT lab, under the supervision of André Niemeyer, Hans de Bresser, and Giulio Di Toro. And what we want to do is, as I said, investigate the rheological behavior of carbonates. And therefore, I will perform friction and flow experiments on both intact carbonate fault rock as well as on fault gouge. So for the frictional part, I will use the hydrothermal rotary shear apparatus. A conceptual figure is at the top left of the slide, which shows how the sample is sheared between two rotating steerings. And for the frictional part, I will use the gas apparatus at the HBT lab, which can generate pressures up to 1 gigapascal and temperatures up to 1,200 Celsius. So with the help of the experiments, we can then define the condition under which the transition from plastic to frictional deformation occurs. And additionally, we plan to perform microstructural analysis down to the nanoscale and identify dominant deformation mechanism. the result will hopefully enable us to test and update microphysical models and see if the observed deformation mechanism that we observed in our experiments also occur on natural faults. And in the upper right corner, there's a figure of a conceptualization of such a microphysical model, which aims to explain the prevailing microphysics at different depths. And yeah, from there on, in addition, existing calcite paleopiezometers to estimate the state of stress at earthquake nucleation depth can then be tested and also updated with the data we gained from our experiments. Yeah, that's from my side.
All right, thank you. Goody. So no questions for Elizabeth? Okay. So DC number 6 is Norwen. She couldn't make it today because she's on the field. So she sent me a video. So I'm going to stop sharing that presentation and put on the video. There we go. Can you see it? Yeah.
Yes.
Okay, so let's go.
Hi everyone, my name is Norwen. I'm sorry because I cannot join you today. I'm part of the DC6, so formation of full damage zones in carbonates on the role in the seismic cycle. I'm working with Giulio Di Toro, Manuel Facenda, and Michele von Trieste, and also Alice Gabriel. So I'm French. I started at INS of Paris in 2019, where I obtained a bachelor's degree with Sorbonne University and a master's degree in geoscience, specializing in solid earths. Then I joined Mines de Paris, where I did a second master's degree and got an engineering degree in geoscience. About my internships, in 2023, I worked on 3D modeling of faults and their relationship with uranium deposits. I did hydrosediment flow modeling in 2022 and 2021, so in Paris and IFP Énergie Nouvelle. At INS, I worked on oceanic intraplate earthquakes with multiple rupture planes. Before that, on seismic interpretation in PST. I studied accretionary prism in Taiwan, but in France, and did the microbiology. Before that, in 2018, I studied the ALP and also sediment dehydration parameters in 2017. So what about field and abroad experiences? In 2022, I went to Greece and we installed GPS stations and analyzed fault movements. And we also looked at microtectonics. I went 1 month in Sicily, Etna, in the Etna volcano for 1 month to collect data from the seismometers and analyze it. I went 6 months in Taiwan to study earthquakes, and I went also to Trieste to study the seismic interpretation and also model the Messinian Mager in the Adriatic Sea. So about my PhD, so I work on the formation of full damage zones in carbonates and the role in the seismic cycle. So on active fault zones hosted in carbonate rocks, there is several hundreds of thick damage zones. What is unknown is how this in situ shattered rocks form. It is during the propagation of seismic rupture, for example, and how they presence affects first the propagation of individual main shock seismic ruptures, the near field wave radiation, and associated strong ground motions. And second, the evolution in space and time of aftershock seismic sequences. So the objectives of the PhD is to get field geology surveys of seismic faults. So go to the field for that. With SEISO to get numerical modeling of individual seismic ruptures. So including the determination of near and far field ground motions, and also a numerical modeling of the seismic cycle. So we have different type of data. We have field study from UniCredit or the University of Padova, photogrammetric techniques, ground survey, and spatial distribution of fault damage zones in active faults. The expected results are first, the discussion of the mechanism of formation and spatial distribution of fault damage zones, how the presence of fault damage zones affects individual seismic ruptures and the evolution of seismic sequences, how the presence of damage zones affect the near field and seismic wave radiation and associated ground motion. Thank you, and if you have any question, you can send me an email at this address. Bye.
Okay, good. All right. So Alexander, you're next, DC7. So so I believe you don't have any slides, yeah?
Yeah, that's correct. I did not prepare any slides because I don't really have any figures for you to show, so you'll have to look at me. So my name is Alexander. I'm from Germany. I studied in Jena, where I did both my bachelor's and my master's. My bachelor's I did in geoscience, so the broad entire field, geology, mineralogy, geophysics. But I started focusing throughout the bachelor more on geophysics, and in the end wrote my thesis on the mechanical properties of the forearc of the Alaskan Aleutian subduction zone. So I already had a bit to do with earthquake physics there. But then for my master's, I stayed in Jena for geophysics. I branched out a bit more. I still had earthquake physics sort of as a topic, but I also did projects involving geothermic aspects or petrophysical measurements in the laboratory, and I even did a machine learning project. So I sort of did everything that came about. But I knew that I wanted, for my master's thesis, I knew I wanted to do numerical modeling, and the project which made sense back then basically dealt with modeling geothermal anomaly in the Thuringian Basin, so small sedimentary basin in central Germany. And we knew there was an anomaly there just from measurements, from data. And I tried to figure out where it comes from just by trying to recreate the temperature field and trying to figure out which sort of mechanisms are important. So I performed fluid and heat coupled transfer simulations back then. But I always knew I wanted to return to earthquakes as a topic because that's what I'm mainly interested in. So a year ago, I was in Croatia, in Petrinja, where in 2020, there was a pretty devastating earthquake. And I was in a field, did some field work there. And basically, from then on, I knew I wanted to focus on earthquakes, definitely. So my project, DC7, is called How Tectonics Affect Seismic Hazard Parameters in Complex Continental Settings. And describing it in one sentence, it's really about modeling contractional continental settings, so mountain building over long time spans. So the reason I was drawn to this is really that it has this tectonic aspect. For this, I will be doing numerical modeling. So I will be employing viscoelastoplastic seismothermomechanical models. Maike already mentioned them for the second project. I am in Utrecht University, which is where she will also be going for that purpose, because I work under Ilona van Dinter as my supervisor, who pioneered much of this. Also, another supervisor of myself is Taras Garia, who pioneered it even before, and then also Elise Gabriel, who does a lot of numerical simulation. And sort of the motivation explaining what these models are is that earthquakes, of course, occur in the upper crust, in the brittle upper crust, but they are also affected by the rheology of the deeper crust and structures deeper in the crust. And it's not enough to just look at the fracturing process itself, because to figure out when an earthquake occurs, you need to know the stress field, and the stress field is impacted by what's happening throughout the deeper depths as well. So that's why these are viscoelastoplastic models, because you need to look at every deformation mechanism, and you need to model all of these deformation mechanisms, because of course in the lower crust you have more slow, viscous, aseismic processes, and in the upper crust you have these very fast bursts of motion when an earthquake occurs, which is also the problem which these models face, that you need to simulate across 10 orders of magnitude in time, from milliseconds up to millions of years, for the tectonic evolution. And what I will be doing is extending existing seismothermomechanical models and adapting them to contractional continental settings, and then determine how different tectonic and rheological parameters affect seismic hazard based on that. And in the end, I will apply it to the BTEX in Spain and constrain parameters there, and try to assess seismic hazard with this physics-based model and compare it to more statistical models for seismic hazard. And maybe from my background, just geophysics and tectonics, what I did during my studying and numerical simulation, you can see why I was drawn to this topic in particular, which I feel like combines everything I've done in the past year. So yeah, I'm really excited to be here and be starting on this work.
Excellent. Thank you, Alexander. Okay. Okay, so next this is Rachel, or Rachel, so that I should pronounce your name. Let me share again the presentation. Okay. So Rachel, that's your turn.
Thank you. Hi, everyone. So I'm Rachel. I'm part of Project 8, which is titled Integrating Physics-Based Earthquake Rupture Models and Seismic Hazard Assessments. If we move on to the next slide, I'm going to give a quick, brief introduction to myself, explain really quickly the project and what we just decided we're going to focus on as the first sort of mini project. So next slide, thank you. So I'm Maltese. I was born in Malta, which is a very small island in the middle of the Mediterranean. So I did my bachelor's there in geosciences and physics, and my thesis was focused on tsunami simulation programs. The motivation to that was because we are a small island, and basically the aim of my project was to compare two different tsunami simulation programs, because we were looking to implement one of them as an early warning system. And the results were quite positive from my project, and in fact, it is TOAST, the one on the left, that is now being implemented as an early warning system for the islands. Then I went on to doing my master's in solid earth sciences at IPGP in Paris, where I did my thesis on looking at the effects of different fault geometries on the seismic rupture propagation. And I did this by basically combining numerical modeling with field observations. So what I tried to do was to try to revisit a historic event. And we were basically interested in what the actual geometry of this particular fault that caused this specific event. And so basically we simulated the same rupture with different geometries and with different epicenters. And we looked at the surface damage patterns produced, and we compared those visually with what was observed on the site to try and conclude on what is the right geometry makeup and the right epicenter of that event. And on to the next slide. My project, so for my PhD, I'm located at LMU in Munich. The project is under the supervision of Alice Gabriel. It's also in collaboration with Sebastian Hock and Una Scotti from IRSN and Jan Klinger from IPGP. And since Alice is located in San Diego, here at LMU, I'm under the guidance of Mathilde Marchandon as well. So the main goals are basically to try to develop a 3D dynamic earthquake rupture scenario for different fault systems by combining nonlinear frictional failure and seismic wave propagation. So that then we can try to produce physics-based forecasts of ground motion and as well as surface displacement and fault interaction. But before doing that, we're going to try to validate the dynamic rupture simulations for chosen events by using multiple different data from fieldwork, geodesy, seismology, and so on. And the aim will then be to try to extract many different mechanically viable earthquake rupture scenarios to be able to then compute physics-based ground motion models that account for the source site and the path effects. And like that, we can construct plausible fault models for hazard assessment. So the overall goal is basically to try to be able to evaluate seismic hazard for any fault system by better understanding the fundamental processes of the earthquake physics underneath everything. And on the next slide, basically just last week we decided what the first project is going to focus on, sort of like the first chapter of the PhD project. And basically I'm going to look at the ground motion of the recent Turkey earthquake. I'm basically going to continue off of the work of a PhD student at Potsdam who made use of EGSIM, which basically is a software that compares ground motion models either against each other or in the student's case against data. So I'm going to try explore further the ground motion effects from that event and look into applying it to hazard assessments. And that's pretty much it from me.
Thank you, Rachel.
Thank you.
Okie dokie. Okay, so let's go on. Thank you. So DC9, that's Katere. I don't know if again the pronunciation is right or not. Katere, that's your turn.
Hi, I'm Khatere Sagatpur. I'm from Iran. Nice to meet you all. I'm going to start with a little bit of my background. I have studied civil engineering in Iran, and my master was earthquake engineering at University of Tehran. My master thesis was about aftershock probabilistic seismic hazard analysis using Monte Carlo simulation, and in which we actually done the seismic hazard analysis for aftershocks that happened in a part of Iran. Could you please go to the next slide?
I'm going to briefly talk about my thesis. That in the first step, a synthetic aftershock catalog was generated by using Monte Carlo simulation. That is a general approach that is actually used in different actually fields. For 3 different time intervals past the main shock, we actually generate. Could you please hear my voice?
Yes, we can hear you, yeah.
Okay. In the next step, a probabilistic seismic hazard analysis is conducted for that region, and the last, the result was the map for seismic hazard for probability of exceedance of 33 and 63% in terms of PGA peak grand acceleration. So in this project, we actually simulate the hypocenter and epicenter of the future earthquakes, and also the magnitude of them. In my project, I will, in this actually thread project, I will do the modeling synthetic catalog of earthquake rupture in complex interacting fault system that is conducted in Pescara in Italy. And that's it.
All right, thank you.
You're
Good.
welcome.
Yeah, I don't know if there are any questions. Okay, not at this stage, I guess. All right, so thanks again. DC number 10, that's okay, that's I don't know if it's Jarod or Yarod, so you will tell me.
It's Jarod.
Jarod. Go ahead.
Okay. Hi everyone, my name is Jarod de Houmange, and I will present you my subject, which is modeling distributed seismicity using innovative approaches. So my main supervisor is Marco Pagani. He works at GEM in Pavia. My co-supervisors are Céline Boval, Anne Soquet, David Marsan, and Federico Agliardi. So the location of my PhD will be at Pavia in Italy, at the Fondazione Global Earthquake Model. This project is in collaboration with University of Milano Bicocca and University Grenoble-Alpes and IRSN. Next slide. So I will present myself really quickly. So I'm a French student of Grenoble in France. I have obtained my OMA degree in Grenoble as well, such as my bachelor degrees in Earth and Planetary Sciences. I specialized myself during my master in natural geological hazard and risks. And I have carried 2 internships at the University of Easter in Grenoble again, in measuring long-term variation in seismic velocities on Pacific Island with excuse me, Aurélien Mordré and other people that I probably don't know now, but and my second internship was on creating a rupture fault model to better constrain the seismic hazard near Lake Iznik in Turkey. My supervisor was Céline Boval and Julia de Sigouillet. You can go to the next slide. So what I love is skiing, because in Grenoble, as you can probably know, there are mountains all around. And obviously this is me. You can go to the next slide. I love climbing as well. As you can see, this is again me, and this is absolutely not Adam Ondra, one of the best climbers in the world. You can go on the slide. I will introduce my subject really briefly again. So, as you can probably know, in probabilistic seismic hazard analysis, PSHA, also known as PSHA, to compute the hazard, we use two typologies of sources, which is fault and distributed seismicity. For distributed seismicity, it's when you are in the region that you don't have the structure of a fault, such as in some region of the France, you don't have the structure of faults, and you want to have the hazard of this region, so you need to do PSHA. So for this type of region, my goal will be to improve the way in which we model distributed seismicity sources in PSHA. So the first part will be focusing on the definition of the geometries of the ruptures, and the second part will be combining this first part and fault sources, and combining yes, this first part and the fault sources. So we can go on the slide. Yeah, this is over. Thank you.
Right. Thanks. Okay, good. So we can go on to the very last presentation. So that's by Julian. So Julian, I will stop sharing because Julian's presentation was too heavy for me to compile. So Julian, you can normally share your presentation.
Yes, sure. Let me know. Can you see my screen?
Yes, we can.
So let me start. So hi everyone. Hi, good Colombian mornings. So it's a real pleasure to meet you here. So I'm going to present a little bit about the last project, the DC11. So it's regarding the assessment of the impact of advanced seismic hazard modeling approaches in earthquake risk. So first of all, so who is Julian or Julian Montejo? So I am a civil engineer from the Universidad de los Andes at Colombia with a master's degree in civil engineering. So in my master's degree, I involved to the earthquake engineering, developing the first crustal model for Bogota for physical-based seismic modeling. And I have some additional formation. So, for example, I have been in Japan in 3 short-term research stays at the NIET and Tokyo Institute of Technology, working for a collaborative project between Japan and Colombia. I did also a postgraduate course in the Pontificia Universidad Católica de Chile about 2019 and 2020, some months before of the pandemic, and the course was about a mitigation of risk for earthquakes and tsunamis. And more recently, I was involved in an earthquake geology training by the OGIN project, where I could teach a little course with Julia Garcia Mayordomo about seismic hazard modeling from seismic faults. About my working experience, so I worked as a research assistant at the Universidad de los Andes, and then I worked as researcher at the Colombian Geological Survey for more or less 7 years, a journey that just finished some weeks ago. And about my working experience, it was principally in seismic hazard assessment. So we have a general scheme of the hazard assessment. So we can define the seismic sources. I have not worked in that, but about the recurrences models, I have experience with the consolidation and managing of the earthquake catalogs and estimation of occurrence models from seismic and geological information. About the ground motion models, I have some experience processing seismic records, estimation of the intensity measurements from the seismic records, the selection and implementation of ground motion models, and I have the opportunity to work developing the new set of ground motion models for Colombia. And for the step 4, that is the calculation of the seismic hazard assessment, I have some experience working principally with the OpenQuake engine for the seismic and risk hazard calculation. So another principal topic I have worked is the side effects. So here we have the general scheme of a earthquake rupture. So the earthquake occur, and the seismic waves are propagating from the earthquake source to the bedrock, and then behind our cities we have the soils, in some cases very soft soils. So the soils and other side condition as the geoforms and the geomorphology can affect the seismic waves in order to generating some amplification in some cases. So that we call the side effects. So with the side effects, I have worked with geophysical exploration and some one-dimensional modeling. I have participated in some seismic sonations, the estimation of seismic record from seismic records, and some experience about the estimation of a probabilistic and deterministic seismic hazard, including the side effects. So about my interests, I have my personal interest, principally my family. So here is my wife and my dog that is very happy because my dog really wants to know Italy. Other personal interests are traveling and cultural immersions, and about my professional interests are the use of new technologies for risk assessment, the science communication, and the culturalization of natural hazards. And one personal interest that I hope in the future can be a professional interest is, why not, because I am Colombian, the coffee. And about the DC-11, about specifically in the project. So my project, as I told you, is about the impact of advanced seismic hazard modeling approaches in earthquake risk. So my principal supervisor is Vitor Silva from the GEM Foundation in Pavia. My co-supervisor is Bruno Paci from UDA in Chieti Pescara. And within the project, we have planned a secondment with James Daleshill in WTW. So about the expected results on the project is a suite of cases openly accessible in the OpenQuake framework about how the different hazard modeling techniques affects the estimation of the seismic risk, and a set of recommendations to perform earthquake scenarios and probabilistic assessment using those approaches that are, for example, the results of the DC9 and the DC10 projects. And for our first year, we are planning a better understanding of how different site amplification methodologies can influence seismic results, seismic risk results. So this is all. So muchas gracias and really thank you.
Good, thanks, Julian. All right, so that's it for the presentations. Just to finish this meeting, I just want to come back to the lecture program. So tomorrow we have an organizational meeting, and we will talk a little bit more about the online lectures. So, I mean, this column here, I mean, DCs that have to present in 2 weeks' time, 4 weeks' time, and so on, will be finalized tomorrow. It's likely that we will wait until the beginning of next year, so in January, for you to present, because it's maybe too early. So, but I will let you know about this. So you don't have to prepare, you know, if you don't need to present. And that's all for the time being for the online lectures. I'll keep you posted about this. So I don't know if you have any questions about the training program, so that Bruno and I could answer. Is everything clear?
I had maybe a logistical question.
Yes.
So I believe all of us have a period of time where we're traveling to another institute of some sort. Financially, how will that work out? Sort of, are there funds to cover our travels? What exactly is this procedure? That's my question.
Bruno, you want to answer?
Yes, I can answer. Yes, your beneficiary, so your main supervisor, as the institute of your supervisor has the money to pay your traveling, and also to give you the salary also for the period of secondment. So in terms of money, only the beneficiary. So your main supervisor has the money. So no money were gone to the partners, so the place where you will do the secondment, but all the costs will be covered by the beneficiary. So your interaction in terms of money will be only with the beneficiary. So in your case, if I remember, sorry, I have so you have to discuss, yes, with Munich about that.
All right, okay, thank you.
Any other question? Maybe just a few words, sorry, David, about also the annual meeting we are organizing tomorrow. As David said, we will have another meeting of the supervisory board, so we will decide more in details. But the idea is to discuss also about the scientific topics of all the work packages. So I think we will ask you again a brief introduction of your PhD topics, but it's okay to use again your slides you prepared for today. It's not a problem about that. You have only to maybe to discuss with your supervisor a bit about how to organize the presentation, and in particular, not only with the supervisor, but also with the work package leader that will introduce the work package. And then inside the work package discussion, we want to have more details on the PhD projects. So you will be in contact with the work package leaders and your supervisor to organize these. I want to ask you also if you can put discussing again with your supervisor, because I think you need your supervisor indication, something more about interaction between your project and the other projects. It's important, as I said at the beginning, that is the whole project want to have results inside our singular PhD project, but also it's important the interaction between us. We focused some possible interaction in our proposal, so we have some ideas, but it's important that you discuss with your supervisor about interaction between your projects and the other PhD projects inside the work package and in general in the whole project. So if you can focus just some ideas, then we can discuss during the annual meeting also these points. And some formal things. Let's try to use the project logo, but also the European Commission logo inside your presentation, in particular where we will use outside. European Commission, we use this. Maybe we will send you some kind of indication. Sorry about that, but also the formal part, because we have to report everything to European Commission, and it's important to follow the few rules they want that we follow. And that's all for me. I don't know if you have some other question. And before the end, I will ask you if it's possible to turn on all the webcams, and so we can do a picture of all together. And maybe we can tweet or put in our Instagram account this first meeting all together.
So Bruno, you take the picture? I'll let you do this.
I can do this. Yes, I try with my laptop. Yeah. Maybe Marco is busy. Oh, we have also Marco. That's fine. Thanks. And thanks a lot.
Okay,
That's
so
good.
yeah, thanks a lot, everybody. So don't forget, in 2 days, next Wednesday, you have the first. It's a long lecture, but it's an interesting one about open science. So please attend it. And the first Monday meeting is in 2 weeks' time. So and I will remind you about this one in due time. Well, in the meantime, enjoy the beginning of your stay and your PhDs. And see you all very soon.
So thank you. Bye-bye.
Bye-bye.
Bye.
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 Everyone.
Bye bye. See you in France.